Alright, in this video we're going to introduce you to the basics of integration by parts. The technique of integration by parts comes from the product rule. We know when we take the derivative of a product of two functions, the result is u dv plus v du. And we can develop a technique for integrating some problems like this by using this idea. If we take the integral of the expression that you see initially, we end up with uv is equal to the integral of u dv plus integral of v du. Using subtraction, we come up with this. And that's the basic idea behind integration by parts, is where we have two separate functions. In an integral, we're going to separate them into two parts, u and dv. And then the integral of u dv is going to be equal to u times v minus the integral of v du. One of the keys is to first, we want to figure out which function we use as u and which function we use as dv in the original. And then we're going to take the derivative of whatever function we find for u and the integral of whatever function we find for dv, and we're going to substitute them in here. The whole idea being that once we do that, our hope is that this integral right here is one that we can take using antiderivatives, and that's going to kind of be our basic idea. So we figure out what u is, what dv is, we find the derivative of u, the integral of v, we substitute them into this basic template, and then we go from there. Now, one of the other keys that will help you as you're first learning how to use integration by parts is, I use LIPET, some people use LIATE as their acronym. This tells us which part of the integral is best to pick as your u. So if you have two functions in an integral, go down this hierarchy as you make your decision of which one you should pick for u and which one you should pick for dv. And so L stands for logarithmic, I for inverse trigonometric, P for polynomials like x to the third or whatever, E for exponential functions, and T for trigonometric functions. And if you pick your u's that way, generally you'll be better off. These two, honestly, are kind of interchangeable, and we'll get to that in a few videos when we talk about integrals of that type. Okay, today we're going to focus on some of the simple ones. So we start in our first examples with simple integration by parts. Basically, I call it this whenever we have a first-degree polynomial that's paired with any of the other function types, or if we have either a logarithmic function by itself or an inverse trig function by itself. Both of those we're going to handle using integration by parts. We haven't really talked at all really about integrating logarithmic functions or inverse trigonometric functions, and that's because we've needed the technique of parts in order to handle the integration of both of those. Alright, so the game plan. We're going to identify our u and our dv. We're going to find the corresponding du and v. We're going to substitute them, and then we're going to integrate. With these simple ones of this style, this will work pretty easily the majority of the time. So I look at my integral in example 1. We're going to find the integral of x times the cosine of x dx. And I look at the types of functions that I have here. I have x, which is a polynomial function, and I have cosine of x, which is a trigonometric function. P comes before t in my hierarchy, so I'm going to choose to have u be x and dv be the cosine of x dx. And the dx always goes with our dv portion when we break them into parts. Now I'm going to find the derivative of u, and I'm going to find the integral of dv. And now, this integral, the integral of x cosine of x, that's the integral of u dv, is equal to u times v, and I'm going to take u and v, multiply them together, u times v, minus the integral of v du. So now I'm going to use v and du in that integrand, multiply them together. And what you see here now is we have an integral that we can find by simple antidifferentiation. The integral of sine of x is negative cosine of x. Don't forget the plus c. And then I'm just going to straighten up my signs here. And there's my integral. Alright, let's go ahead and do example 2 here also. The integral of the quantity 2x plus 3 times e to the x is polynomial, exponential. P comes before e, so that's going to be our u. U equals the quantity 2x plus 3. And dv is going to be e to the x dx. I'm going to find the derivative of u and the integral of v, of dv, pardon me. Alright, and now integral of u dv is going to be u times v minus the integral of v du. And this I can integrate without any great difficulty. And now if I want to clean this up a little bit, I have, if I distribute the e to the x through the first set of parentheses, I have 2x e to the x plus 3 e to the x minus 2e to the x plus c. And so this is equal to 2x e to the x plus e to the x plus c, or if I wanted to go back to a factored form. So either one of these will be acceptable for you here. Alright, we'll end this video here and go through a few more examples in the next one.